Good morning, students. Today we will learn kinematics. Already we have completed vectors, which is a very important for mechanics. Ee roju manam kinematics chudam. Vectors complete chesam. Vectors mechanics lo important role play chestundi. One dimensional horizontal motion. So one dimensional horizontal motion. Horizontal motion. Displacement. Displacement. Displacement is vector. Displacement is defined as path traced by the body which is in motion in a straight line from initial point to final point. Body is moving from point A to point B in straight line. This is displacement. If it moves in a different line from A to B, then curve 2, curve 3 is distance. Curve 1 is displacement. Displacement means it should be a straight line from initial point A to final point B. Distance is need not be in a straight line. So when we observe path covered along 2 and along 3 is more than along 1. But 2 and 3 path are in curved path. They are not in straight line to join from initial point to final point. So 1 is said to be from A to B is said to be displacement. Displacement, when we compare with the distance, distance is always greater than displacement. So when we take the ratio of distance by displacement is greater than 1. Distance by displacement is greater than 1 for a body which is in motion. Distance can never be 0. Distance eppudu kuda oka body motion lo unte distance eppudu kuda 0 undadu. Displacement 0 avvachu, negative avvachu, positive avvachu, but distance is always greater than 0 for a body in motion. Whereas displacement can be positive, can be negative or 0. So displacement negative eppudu avutundi? When does we assume that displacement is negative? For example, if a body starts from A, goes to B and again returns back to C, then A to B is in forward direction, B to C in opposite in direction. If it comes back to A, then displacement is 0. But if it going to up to C in backward direction, AC is negative displacement. That means initial point nundi munduku vellin tarvata when it comes back off initial point, then displacement is negative. So displacement can be negative, positive, 0, but the distance is always positive. That is, distance is always greater than 1 for a body in motion. Though displacement for circular path, displacement for circular path, if a body is in circular motion లో బాడీ తీసుకుంటే, let us take the center of the circle as O. It is moving from a point A to B. Then the curve AB is distance. Whereas the straight line joining A and B, if you join straight line A to B, is displacement. Straight line AB is displacement. So already we discussed, displacement means it should be a straight line from initial point to final point. If it subtends an angle theta at the center, when a body is moving from point A to B, it is displacing, subtending an angle theta at the center, then displacement is given by, if I take that triangle separately AB, I'll take this as the radius R of the circle, R O A to B. I will drop a perpendicular bisector, so this angle will become theta by 2 and this is also theta by 2. Let us take this is x and this is x, that is total displacement is equal to 2x. Since displacement is a vector, let me represent as S bar. S bar equals 2x. From the triangle, I can take sin theta 2 equals, opposite is x, hypotenuse is r. So x is equal to r sin theta by 2. But we want displacement. So displacement is what? 2x. So displacement is equal to 2x. 2x, what is the x value we got? R sin theta by 2. So this is displacement for a body in circular motion. This is the way we should calculate the displacement of a body in circular motion. Oka body circular motion lo unnappudu displacement manam ila calculate cheyali, 2r sin theta by 2. R is the radius of the circle, theta is the angle subtended at the center. అదే డిస్టెన్స్ కావాలి అంటే డిస్టెన్స్, ఇదే కేసులో డిస్టెన్స్ కావాలి అంటే సింపుల్గా డిస్టెన్స్ ఈజ్ డినోటెడ్ బై ఎస్. ఎందుకంటే బికాజ్ డిస్టెన్స్ ఈజ్ స్కేలర్ కాబట్టి ఇది ఎస్ బార్ పెట్టకూడదు, ఎస్ అని పెడతాం. ఎస్ ఈజ్ ఈక్వల్ టు, డిస్టెన్స్ ఈజ్ ఈక్వల్ టు theta into radius, where theta measured in radians. So this is how we'll calculate distance and this is how we'll calculate displacement for a body in circular path. Example, when we take example, if a body is in circular motion of radius r equals 1 centimeter, is asking us to find distance and displacement for 3/1/4 revolutions. 3/1/4 revolutions. Find distance and displacement for 3/1/4 revolutions. First we will take displacement. We will calculate displacement. Displacement. Total how many revolutions? 3 revolutions. For 1 revolution, displacement is 0. Therefore, for 3 revolutions, displacement is 0. Remaining is how much? 1/4 revolution. 1/4 revolution means it will make 90 degrees. For 1/4 revolution, theta subtended at the center is pi by 2 for 1/4 revolution. So, put displacement equation, will apply it. S bar equals 2r sine of theta by 2 is the displacement equation. When we substitute it now, 2 radius is 1 centimeter, sine of theta is pi by 2, you will get pi by 4. So, S bar 2 sine pi by 4 is 1 by root 2. So, when we rationalize it, root 2 by root 2, root 2 2. So, it is root 2 centimeters is displacement. But distance when you work out, distance is equal to S theta. Theta is how much? Distance is equal to 3 revolutions. 3 into 2 pi r plus 1/4 revolution. 1/4 of 2 pi r. For 3 revolutions, it is 3 into 2 pi r. Because for 1 revolution, distance is 2 pi r. So, remaining is 1/4 revolution for 1/4 of 2 pi r. Since r is 1 centimeter, so ultimately what will get? 6 pi plus 2 get cancelled. So, it is pi r by 2. Ultimately we are getting 13 pi by 2 centimeters. So, this is how we can calculate displacement and distance for a body in circular motion. So, distance is always greater than displacement for a body in motion. Distance never be negative or 0 for a body in motion. It is always greater than 0. Displacement can be 0, positive or negative. Actually speaking, kinematics is totally based on idea. By observing the question, you should analyze what is the data given and what is the required data, how to bring the relation between different physical quantities. That is how the physics problem is solved. And whenever you are reading a physics question, it should be read part by part. That is most important. So, equations of linear motion, that is one dimensional. So, we know the very familiar. One is V is equal to U plus AT, where V is final velocity, U is initial velocity, A is acceleration, uniform acceleration. Next equation you are familiar, ut plus half at square. S is the displacement made by the body, U is initial velocity, A is acceleration. The next equation we are having V square is equal to U square plus 2AS. S is again displacement. Another equation we are having is Snth equation, U plus A by 2 into 2n minus 1. These are the 4 equations generally will be coming across in the complete kinematics. When a body starts from rest, U, that is initial velocity, will be 0. When a body comes to rest, V, that is final velocity, should be 0. When a body is moving with constant velocity, then acceleration will be 0. So, let me repeat. If a body starts from rest, initial velocity is 0. If a body comes to rest, final velocity is 0. If a body moves with a constant velocity, therefore acceleration is 0. So these are the basic points we should remember whenever we are applying. Now, nth equation. Nth equation means what is the distance covered by a body in a particular second. For example, if we take a body is in motion for 5 seconds, total motion of the body is 5 seconds. Let us divide its motion into 5 parts, 1, 2, 3, 4, 5 parts. This I will name it as first second, second second, third second, fourth second and fifth second. Total time of journey is 5 seconds. First second, second second, third second, fourth second, fifth second. If it starts with a from rest, body starts from rest, therefore initial velocity will be 0. And moving with uniform acceleration, that is, let us take A is equal to 2 meters per second. So first bit we will try to calculate distance covered in 5 seconds. Distance covered in 5 seconds. Here we have taken the body is moving in straight line. So distance and displacement will be in same if the body is moving in straight line without any change in direction. So from the equation, S is equal to ut, u is 0 plus half, A is 2 meters per second and time is 5 seconds. So it is 5 square. So distance covered will become 25 meters. This is the total distance covered in 5 seconds. If I want the distance in second bit will do it. Distance in second. Distance in second. He is asking particularly in second how much distance it has covered. So we will apply nth equation to calculate distance covered in second. U 0, because already he said it starts from rest. U 0 plus, with what acceleration it is going? Acceleration is 2 meters per second square. So it is 2 by 2 into 2 n. Which second we require? Second minus 1. So nth equals 2 by 2 is 1. So 2.2, that is 2 into 2 is 4. 4 minus 1 is 3 meters. So it has covered 3 meters in second. If I want in fifth second, distance covered in fifth second. Distance covered in fifth second is asking in fifth second. So again we should apply nth equation. Nth is equal to, nth equation what we are having? U plus A by 2 into 2n minus 1. U 0 plus A 2 meters per second square. N is 5 because we want in fifth second. Now this is 10 minus 1 which is equal to 9 meters. So this is the how we will apply nth equation. Distance covered in a particular second is what we do for nth equation. We'll observe one more example. A body in motion, a body in motion covers x meters in first 2 seconds. And y meters in next 2 seconds. A body in motion covers x meters in first 2 seconds and y meters in next 2 seconds. Body in motion will take starts from rest. Body in motion starts from rest, covers x meters in first 2 seconds and y meters in next 2 seconds. Find x by y. Find x by y. He is asking us to find x by y. Since body starts from rest, we'll apply x is equal to ut0 half a t square in how many seconds? 2 seconds. So x is equal to 2a. Let me write this as first equation. Now coming to next 2 seconds. So we'll continue here. This is how the total journey is given. This is first 2 seconds. This is next 2 seconds. This is x meters. This is y meters. After 2 seconds, the body will be coming here. It starts from 0 meters per second. But after 2 seconds, its velocity will not be 0. It has some velocity. That is the reason what you should do. Again, you should start from initial point. So total distance will become x plus y. Initial velocity is 0 plus half a t square. Now you should take total time. Total time is how much? 2 plus 2 seconds, 4. Because after 2 seconds it will get some velocity here and you don't know what is the velocity here. That is the reason again we should take from beginning, initial point where it starts. The point it starts, its initial velocity is 0 and total time of journey is 4 seconds. Therefore, x plus y is equal to half a t square. So x plus y is equal to half a 16 or x plus y is equal to 8a. Already we got x is equal to 2a. So I'll write this as x plus y is equal to 2 into 2a into 4. So what is the 2a value? 2a value is x. So now I can write this as x plus y is equal to 4x. So y is equal to 3x. Therefore, what is the value of x by y? Therefore, x by y, x divided by y is equal to 1 by 3. So this is how we can apply the equations of kinematics by simple logics. ఇప్పుడు ఇంకో ఎగ్జాంపుల్ చూద్దాం. A bullet fired into a wooden plank. Wooden plank loses 1 by nth of its velocity. 1 by nth of its velocity. How many such planks are required to stop the bullet completely? How many such planks are required to stop the bullet completely? So, ఒక బుల్లెట్ ఇనీషియల్ వెలాసిటీతో వెళ్తుంది ఇంటూ ఏ వుడెన్ ప్లాంక్. ఆ వుడెన్ ప్లాంక్లోంచి బయటికి వెళ్ళేటప్పుడు ఎంత వెలాసిటీ లాస్ అవుతుంది? 1/nth లాస్ అవుతుంది ప్రతి ఒక్క వుడెన్ ప్లాంక్లోంచి. బుల్లెట్ని కంప్లీట్గా ఆపడానికి అలాంటివి ఆ మెటీరియల్వే ఎన్ని ప్లాంక్స్ అవసరం? హౌ మెనీ ప్లాంక్స్ ఆర్ రిక్వైర్డ్ టు స్టాప్ ద బుల్లెట్ కంప్లీట్లీ? ఆ సేమ్ నేచర్ మెటీరియల్ ఉండాలి, సేమ్ థిక్నెస్ ఉండాలి. సో ఇక్కడ ఫైనల్ వెలాసిటీ 1/nth ఆఫ్ ఇనీషియల్ వెలాసిటీ ఉంది, ఫైనల్ వెలాసిటీ ఉంది, టైం లేదు. దేర్ ఈజ్ నో రెఫరెన్స్ ఆఫ్ టైమ్ ఇయర్. సో వీ షుడ్ సర్చ్ ఫర్ అన్ ఈక్వేషన్ వేర్ ఇనీషియల్ వెలాసిటీ, ఫైనల్ వెలాసిటీ షుడ్ బి దేర్ అండ్ డిస్టెన్స్. అందులో టైం ఉండకూడదు, ఎందుకంటే మనకి ప్రాబ్లంలో టైం డేటా మీద లేదు డేటా అంతా. కాబట్టి ఇచ్చిన డేటా ప్రకారంగానే యాజ్ పర్ ద డేటా ఓన్లీ వీ షుడ్ సెలెక్ట్ ద ఈక్వేషన్. సో అవర్ సెలెక్షన్ విల్ బి v² minus u² equals 2as. That is the best way to apply. So we'll apply v² minus u² equals 2as. v² final velocity 1/nth of initial అంటే u/n of initial మైనస్ u². ఇక్కడ బాడీ వెలాసిటీ తగ్గుతుంది కాబట్టి ఇది డీసెలరేట్ అవుతుంది, -2as. ఓకే, x డిస్టెన్స్ కవర్ చేసింది అనుకుందాం. ఆఫ్టర్ కవరింగ్ థిక్నెస్ x డిస్టెన్స్ కవర్ చేసిన తర్వాత, అంటే వేర్ x ఈజ్ ద థిక్నెస్ ఆఫ్ ఈచ్ ప్లాంక్. x is thickness of each plank. Thickness of each plank. X is thickness of each plank. Now finally second equation, it should come to rest. Starts with initial velocity u² minus 2a. Total how many planks are required? Let us take capital N planks are required. Now equation 1 and equation 2. When we simplify it, so we'll divide it u² by n² minus u² by minus u² is equal to 2a cancel అవుతాయి, remaining is x cancel అవుతుంది 1/n. ఇక్కడ మైనస్ సైన్ గ్రేటర్ వాల్యూ, సో u² కామన్ తీసేద్దాం. ఇట్ విల్ బికమ్ 1 minus 1/n² by 1, the 1 by capital N. So you can observe here it is 1/n² minus 1 వస్తుంది. సో దాన్ని రివర్స్ చేస్తే we'll get 1 minus 1/n². సో ఇక్కడ సింప్లిఫై చేస్తే n² minus 1 by n² is equal to 1/n. So capital N is equal to how much you are getting? Capital N is equal to n² by n² minus 1. మళ్ళీ ఒకసారి రిపీట్ చేద్దాం ఫస్ట్ నుండి. సో క్లియర్గా అర్థం చేసుకోండి, ఇది ఇంపార్టెంట్. ఇనీషియల్గా బాడీ స్టార్ట్స్ విత్ సమ్ వెలాసిటీ u, వుడెన్ ప్లాంక్లోంచి బాడీ వెళ్ళాలి. ఆఫ్టర్ కవరింగ్ u వెలాసిటీతో వెళ్తుంది, ఇట్ ఈస్ కమింగ్ విత్ u వెలాసిటీ. ప్లాంక్లోంచి బయటికి వెళ్ళేసరికి దాని వెలాసిటీ u/nth, లూజెస్ u/n వెలాసిటీ, 1/nth వెలాసిటీ లాస్ అయింది. సో ఇంత వెలాసిటీతో బయటకు వచ్చేసింది, రైట్. 1/nth వెలాసిటీ లాస్ అయింది కాబట్టి రిమైనింగ్ వెలాసిటీ ఈజ్ ఈక్వల్ టు u minus u/n. So u minus u/n is a final velocity. Last velocity is u/n. So అప్పుడు ఏమవుతుంది మనకి u minus u/n whole square minus u². ఈ రకంగా ఇంకా సింపుల్గా ఉంటుంది మీకు. So when we simplify this one, if you take u² common from here, u² into 1 minus 1/n whole square minus u² is equal to minus 2ax. మళ్ళీ ఈక్వేషన్ ఇలా రాశాను. మళ్ళీ ఈ ఈక్వేషన్ యాజ్ ఇట్ ఈజ్ 0 minus u square is equal to minus 2a nx. ఈ రెండింటిని డివైడ్ చేద్దాం. డివైడ్ చేస్తే u square క్యాన్సిల్ అవుతుంది. సో రిమైనింగ్ ఈజ్ 1 minus 1 by n square by 1. ఈ రెండు ఈక్వేషన్స్ని డివైడ్ చేస్తున్నాను. అంటే u square క్యాన్సిల్ అవుతుంది. ఇక్కడ -1 ఉంది కాబట్టి ఈ -1 కామన్ తీస్తే 1 minus 1 by n by whole square is equal to ఇక్కడ మీకు వచ్చేసి 1 by capital N. సో సింపుల్గా capital N is equal to what now? ఈ సింప్లిఫై చేస్తే ఏమొస్తుంది? 1 minus of 1 plus 1 by n square minus 2 into 1 by n is equal to 1 by capital N. ఇప్పుడు సింప్లిఫై చేద్దాం. సో 1 by capital N వాల్యూ ఏమొస్తుంది? 1 by capital N is equal to ఈ మైనస్ సైన్ మల్టిప్లై చేస్తే లోపలికి 1 minus 1 minus 1 by n square plus 2 by n. -1 plus 1 cancel అయిపోతుంది. So what is remaining now? 1 by capital N is equal to 2 by n minus 1 by n square. So LCM is n square. This is 2n minus 1. So number of planks required is n square by 2n minus 1. These many planks are required to stop the bullet completely. Question చూడండి. A bullet fired into a wooden plank loses 1 by nth of its velocity. How many such planks are required to stop the bullet completely? Final velocity, initial velocity, distance. ఈ మూడిట్లో రిలేషన్ ఉంది. That's the reason I am using v square minus u square equals 2ax. Let us think x is the thickness of each plank. Bullet u velocity తో వెళ్తుంది. ఎంత లాస్ అవుతుంది? u by n loss. u by n is loss. అంటే రిమైనింగ్ వెలాసిటీ ఎంత? u minus u by n. ఇప్పుడు ఫైనల్ వెలాసిటీ స్క్వేర్ మైనస్ ఇనీషియల్ వెలాసిటీ స్క్వేర్. అలాగే టు స్టాప్ కంప్లీట్లీ అన్నాడు కాబట్టి ఫైనల్గా మొత్తం 0 రావాలి. ఇనీషియల్ u ఎన్ని ప్లాంక్స్ కావాలి? మనం సింప్లిఫై చేసాం. సింప్లిఫై చేస్తే నంబర్ ఆఫ్ ప్లాంక్స్ క్యాపిటల్ N ఈజ్ వాట్? నంబర్ ఆఫ్ ప్లాంక్స్ రిక్వైర్డ్ ఈజ్ n స్క్వేర్ బై 2n minus 1. సో ఇలాగా బేస్డ్ ఆన్ ద ప్రాబ్లం మనం డేటా ఇచ్చిన బేస్ మీద ఈక్వేషన్ సెలెక్ట్ చేసుకోవడం, ఆ ఐడియా అప్పుడు రావాలా. కొన్నిసార్లు డిఫరెంట్ మల్టిపుల్ కాన్సెప్ట్స్ కూడా ఇవ్వచ్చు. సో టోటలీ ఐడియా పైనే డిపెండ్ అయి ఉంటుంది. ఈక్వేషన్స్ కేవలం ఈక్వేషన్స్ అనేది మ్యాథమెటికల్ అప్రోచ్ కోసమే. ఫిజిక్స్ టోటలీ డిపెండ్స్ ఆన్ ఐడియా. ఇంకో ప్రాబ్లం చూద్దాం. ఎగ్జాంపుల్, a body covers first half of the total distance in t1 seconds and total distance in capital T seconds. Body covers first half of the total distance in t1 seconds and total distance in t seconds. If it starts from rest, find the relation between capital T and T1. Body starts from rest, total distance S అనుకుందాం. total distance S అయితే ఫస్ట్ హాఫ్ S by 2 అవుతుంది, సెకండ్ హాఫ్ S by 2. ఫస్ట్ హాఫ్ T1 seconds, సెకండ్ హాఫ్ T2 seconds. Total time is what? T1 plus T2. First half T1 seconds. So S by 2 is equal to half a T1 square. So ikkada what is the value of T1 you will get? T1 is equal to 2 cancel అయిపోతే root of S by A. But we want relation between T1 and T2. If you take total time ki equation ఏమవుతుంది root of 2S by A. So అప్పుడు T is equal to ఎలా రాయొచ్చు 2 times of root of S by A is what? T1. Root 2 times of T1. So this will become the relation between capital T and T1. Total time taken is capital T, T1 plus T2. First half is T1. First half distance ante S by 2. S by 2. A equation apply చేస్తున్నాం. S is equal to ut plus half a t square. S u0 half a t1 square. So 2 cancel అవుతుంది. S by a t1 square కాబట్టి root వెళ్ళిపోతుంది. Root of S by a you will get. But total time is what? T1 plus T2. Total time, total distance is S. అప్పుడు మనం S is equal to half a t square apply చేస్తే time taken is root of 2S by a. But already root of S by a ఏమొచ్చింది T1. ఇక్కడ మిగిలింది ఏంది ఇంకా root 2. So T is equal to root 2 T1. So in this way you can apply the logic and bring the relation. One dimensional vertical motion. We will discuss for freely falling body. Freely falling body. Freely falling body. Initial velocity is 0 because it is dropped freely. S is equal to h. So first equation will get velocity after t seconds. V is equal to gt. H is equal to half gt square. That means h proportional to t square. So ratio of heights in this connection is equal to 1 square, 2 square, 3 square, so on. That is 1:4:9:16:2, so on. Ratio of the heights covered by a freely falling body in 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds is 1:4:9:16, so on. And next equation is, we'll be applying v square minus u square. So v square is equal to 2as. A is g, height is h. So v is equal to root of 2gh. This is final velocity on reaching the ground or after covering a height h. Final velocity of a freely falling body after covering a height h. If you want to calculate average velocity, you can take initial velocity plus final velocity by 2 when acceleration is uniform. If acceleration is uniform, you can apply this one, uniform acceleration. When acceleration is uniform, average velocity is initial velocity plus final velocity by 2. So average velocity, since it is u is 0 plus root of 2gh by 2, so average velocity will be root of 2gh by 2. So ultimately you will get root of gh by 2 when you simplify this one. When you go for s-nth equation, s-nth equation is now h-nth equation. u0, so it is g by 2 into 2n minus 1. Now h-nth is proportional to 2n minus 1. So ratio of heights covered in this case in first second, second second, third second, so on is 1:3:5:7:9. So on. These are said to be Galileo's odd numbers. What is the difference between these two? It is the ratio of heights covered in 1 second, 2 second, 3 seconds. This is first second, second second, third second. 1:3:5:7:9, and this is 1:4:9:16. So from here we can write h by hn relation. H proportional to t square, I will write it as n square, hn proportional to 2n minus 1. So this is what we can make the relation between h2 hn n square by 2n minus 1. Now if a body, freely falling body covers x meters in nth second, and what is the distance it will cover in n plus 1th second? It covers x meters in nth second. Nth second we don't know, some second during the fall. Immediate next second is n plus 1th second. So what is the distance it will cover in n plus 1th second? So let me apply Snth equation. Snth equation is what? Snth is equal to u plus g by 2 into 2n minus 1. This is the basic equation. U 0 because it is a freely falling body. How much distance it will cover? X, g by 2 into 2n minus 1. Next second we want the distance. Let us say the next second distance is d. So d is equal to g by 2 in which second? N plus 1th second minus 1. So d is equal to g by 2 into 2n plus 2 minus 1. So now I will multiply g by 2. G by 2 into 2n minus 1 plus 2 into g by 2. So this will become x plus g. This is the distance covered in which second? Which second? N plus 1th second. So this is how the freely falling body covers a distance of x plus g in downward direction. If it is going upward, what is the distance covered in n minus 1th second? You will get n minus 1th second. Here you will be getting x minus g. What we got here? Ex plus g. So in this way we can see what is the distance covered by a freely falling body. In nth second he has given x. In n plus 1th second x plus g. This is the way we will work out. Same way n minus 1th second పైకి అడిగాడు అనుకోండి, you will get x minus g. And if you take a freely falling body, first 1 meter, second 1 meter, third 1 meter, it will take t1 seconds, t2 seconds and t3 seconds. Since it is a freely falling body, first 1 meter time taken is root of 2h by g. For second 1 meter again we should go for calculate for first 2 meters. First 2 meters. Calculate for first 2 meters total time. If I will take t1 plus t2 which is equal to root of 2 into 2, total height is 2, so 2h by g. So t1 plus t2 is equal to, already we got root of 2 by g is what? T1. So this will be what? T1 plus t2, what will get? Root of root 2 into root of 2 by g. But what is 2 by g? T1. So what is the total time we are taking? Capital T is equal to root 2 into root of 2 by g. So from here what is T2? T2 is equal to what? Capital T minus T1. So root 2 minus 1 into root of 2 by g. This is the time for second 1 meter. Time for second 1 meter. Time for second 1 meter. Second 1 meter. T2 is equal to T capital T minus T1. What is capital T? For first 2 meters total time is root 2 into root of 2 by g. Time for second 1 meter is what? T2 is equal to total time for first 2 meters minus time for first 1 meter. So root 2 minus 1 into root of 2 by g. Similarly for third 1 meter you will get root of 3 minus root 2 into root of 2 by g. So for nth 1 meter, when we take the ratio of times, The ratio of the times will become what now? T1 is to, T2 is to, T3 is to, up to nth 1 meter, it will become 1 is to root 2 minus 1 is to root 3 minus root 2 is to, so on up to root nth 1 meter minus root of n minus 1. This is the ratio of times to cover first 1 meter, second 1 meter, third 1 meter and up to nth 1 meter for a freely falling body. When you go check the vertically projected up body, this is also one dimensional motion, vertically projected up bodies, vertically projected up bodies. So in this way you can apply number of applications either for vertically projected up body or freely falling body. Both are in one dimension only, either going straight upwards or coming straight downwards. Vertically projected up body, final velocity will be 0 at maximum height. So acceleration will be minus g because it is decelerating going upwards against the gravity. So A is equal to minus g. So when we take the equations of motion, final velocity is equal to u minus gt, velocity after t seconds. So in this case, what will be the average velocity? U plus v by 2. So which comes out as u plus u minus gt by 2. So 2u minus gt by 2 is average velocity after t seconds. Now h is equal to ut minus half gt square. Second equation. T square means the body will be at same height twice in total motion. Going up it will cover t1 seconds and in return journey also it is at a height h in upward direction. While it is returning again it will be at same position by taking t2 seconds. The body will be at same point P in upward motion as well as in downward motion. While going up, it will cross the point P. While coming down, again it will cross the point P. While going up, it is crossing the point P in t1 seconds. In return journey, it is crossing the point P at t2 seconds. That means a vertically projected up body, it will be at same level twice in its total motion. That's the reason you will get h is equal to ut minus half gt square when we take the quadratic equation here. So half gt square minus ut plus h is equal to 0. So we'll apply the concept of minus b plus r minus b plus r minus root of b square minus 4ac by 2a quadratic equation, roots for quadratic equation. X is a variable in our quadratic equation. Now what is the variable here? ut. What is the variable here? T is the variable. So we'll substitute now. So what will get t value? T is equal to minus b. What is b here? U plus r minus root of u square minus 4ac. 4 a value is g by 2, c value is h by 2, a value is g by 2. So t is equal to u plus r minus root of u square minus 2gh by g. So t1 will be what? U minus root of u square minus 2gh by g. t2 is equal to u minus root of u square minus 2gh by g. So when we add t1 plus t2 is equal to 2u by g, which is time of flight. U is what from here? U is 1 by 2 g into t1 plus t2. So when a body is projected vertically upwards, it is twice at the same point, going up and coming down. In going up, it is taking a t1 seconds. T1 value is u minus root of u square minus 2gh by g. Coming down, from the point of projection, we are measuring the time. It will take a time of u plus root of u square minus 2gh by g. If you add t1 and t2, you are getting 2u by g. That means it is time of flight, where u is the velocity of projection. So in this way, either you can calculate h value also. If you want to h here, h you will be getting, on simplifying, you will be getting half g t1 t2. When you substitute the value of u in this equation by taking h is equal to u t1, suppose if I substitute that h is equal to u t1, h is equal to u t1 minus half g t1 square. U value is this. On substitution and simplifying, you will get half g t1 t2. This is the height above the ground of point P, where the body is at twice while going up and while coming down. H is equal to half g t1 t2. Next equation is v square, final velocity minus u square is equal to minus 2g h max. So maximum height covered by a vertically projected body is u square by 2g. So this is final equation. We will check one more example. A body projected from the top of a tower. Body projected from a top of a tower of height h, vertically upward, it goes to the maximum height and returns. It is projected vertically up with a velocity u. Maximum height above the tower is h max. From there it will return. When it comes to the same level of, it will come back with u velocity, and here it will touch the ground with velocity v. Here the displacement of the body on reaching the ground, is minus h. Therefore, the equation will become minus h ut minus half gt square, or h is equal to half gt square minus ut. This is the height of the tower, from where the body is projected vertically up, goes to the maximum height and reaches the ground in a time of t seconds. To calculate time here, again we will apply quadratic equation. So half gt square minus ut minus h is equal to 0. So when we apply the same roots equation, minus b plus r minus under root of b square minus ac, t is equal to minus b minus u plus r minus, I will go for plus sign only, minus b plus r minus root of u square minus root of b square minus 4ac by 2a. Previous case whatever we have done, u square minus 4a value is g by 2 into c value is minus h, everything in under root. So by g you will get, so ultimately time is equal to u plus root of u square minus plus 2gh by g. This is the time taken by the vertically projected body to reach the ground. If you go for velocity, v square minus u square is equal to 2gh. So final velocity on reaching the ground, u square plus 2gh. If I take the height covered, where h is the height, it will come back to this position with velocity v and reaches the ground with velocity v. U and this is v. with whatever the velocity you project up, with the same velocity it will come to the same level. U at this point is equal to same at this velocity. It starts from U here and reaches the ground with V, height is h. Therefore, V is equal to U square plus 2gh. If you want to calculate h max above the tower, h max above the tower is what? U square by 2g. So, in this way you can get number of relations for body projected vertically up from a top of a tower. Body projected upwards with velocity u from a height h of the tower. The displacement of the body from the initial discussion, initial point to final point. Let us take the initial point as A, final point as B. It is coming downward, therefore displacement is minus h. From the equation s is equal to ut plus half at square, we got minus h is equal to ut minus half gt square. So, I am taking a negative sign, it is h is equal to half gt square minus ut. So, half gt square minus ut is minus h is equal to 0. By applying the equations of roots, minus b plus r minus under root of b square minus 4ac by 2a. Substituting, we will take only the positive value instead of plus or minus. I am taking u plus minus b. Minus b means in the place of b what we are having? U. So, it is what? Minus of minus plus u plus or minus. Minus I will not take because time is taken in positive. Root of u square minus 4ac by 2a. C. A is what? G by 2. C is what? Minus h. So, minus h. 2a. G by 2 into 2 get cancelled. G is remaining. Suppose if he is asking what is the final velocity of the body on reaching the ground, then what will get? V square minus u square equals 2gh, where h is the height of the tower. Because it starts coming down from the top of the tower with velocity u, even though you are projecting up with velocity u, again it come back to the same level with same velocity. Therefore, final velocity on reaching the ground is v is equal to u square plus 2gh. If you want to calculate the height above the top of the tower, height above the top of the tower is what? We will apply h max is equal to u square by 2g. So, these are the relations you will be getting. For example, if I will go for an example, if a body reaches the ground with velocity 3u, find height of the tower. Find the height of the tower. So, what will get the height of the tower? We will apply equation. So, this is what? V square equals u square plus 2gh. V square, V has given what? 3u. So, this will become 9u square is equal to u square plus 2gh. 8u square is equal to 2gh. So, therefore, what is the h value you will get? H is equal to 4u square, 4 times 4u square by g. So, this is the height of the tower you will get. Here I have taken a body reaches the ground with velocity 3u. Find the height of the tower. It is coming down with velocity 3u. I am substituting in this equation. 3u square whole square is 9u square, 8u square is 2gs. So, h is equal to 4u square by g.